All right, let's talk about equivalent expressions again. And so this time what we're going to do is I've listed two expressions and we are going to decide if they are equivalent to each other. So we're trying to figure out if they are equal. That means they need to equal the same amount or look the same on both sides. And if they're equal, we're going to keep the equal sign. If they are not equal, we're going to put a slash through it because that represents not equal. Okay? All right, so let's take a look at the first one. So this is a numerical expression. The first three are numerical, and then the next four are algebraic. All right, so let's look at this one. So if you look here, I'm going to think about this side has to equal that side, which means they need to equal the same amount, okay? So if you look here on this side, remember I always do parentheses first because that's what PEMDAS tells me to do. So 4 plus 4 is 8. So then if you see, I would have 8 here because that would be canceled. And 8 times 3, oh, that looks the same on this side. 8 times 3, and then we add 3. And when we do 8 times 3 and we add 3, you get 27. So this side would equal 27, which this side also equals 27. So these are equal or equivalent expressions. So we would keep the equal sign. Okay, on this one, let's take a look at this. So this one, it looks like I have all the same things. I have 3 times 5 plus 6. I have 3 times 5 plus 6. Okay, but on this side, as you can see, I have a parentheses where this side I don't. So if I think about PEMDAS, I'm going to solve here. It tells me to do the parentheses first. So 5 plus 6 is 11. And then if I times that by 3, I get 33 on this side. So this side is 33. Let's look at this side. Well, this side, PEMDAS says there's no parentheses, so the first thing I need to do is multiplication. So that would be 15 plus 6. And 15 plus 6 equals 21. So as you can see, this side equaled 33. This side equaled 21, so these are not equal to each other. They look the same, but unfortunately when I solve them with order of operations, I get two different answers, which makes this not equal. Okay, let's look at this one down here, okay? So this one, let's see. Let's solve this side, so that's 21 plus 7. And 21 plus 7 is 28. And then over here, PEMDAS says to add first, or do the parentheses first. So that's 4 times 7 equals 28. Oh, so look. When I solve both, I get 28 on both sides. They look a little bit different, but remember, equivalent expressions can look different, but as long as they equal the same amount, we're going to say that these are equivalent then. They are equal to each other. All right, let's look at the algebraic ones. So let's look here. I have 4 n's. So this is telling me I need 4 n's equals 4 plus 4 plus 4 plus 4. Okay, this one's a problem because here, remember, this means I have 4 n's. So this should have been n plus n plus n plus n. And n plus n plus n plus n, that equals 4n. This does not equal 4n. This would be backwards. So this is not equal. This is written incorrectly. So those are not equal to each other. All right, let's look at this one. So this one, I have 3 t's. So if you look here, I have 1, 2, I have 3 t's that are added together. So these ones are equal to each other. All right, let's look at this one. So this one I have 4 times a plus 3 is equal to 3 plus 4a. So this one has no dot. I see that difference. This one does. And it's written backwards. As you can see, this one's been flipped around. So these two would still be equal to each other because remember, when there is no dot, these two mean the same thing. And with addition, you can flip it around and it's still means the same amount. So these two are equal to each other. And then let's look at this last one. So we have 5u plus u. So if we put the 5u and the u together, we get 6u. So I agree with that. And then it says minus 2, minus 2. So these are also equal to each other because these two together will give you that, and then these still look the same. So those are equal to each other.